At 0147 hours, operators at a launch site in Ukraine prepared to strike the Kirishi oil refinery. The target was 1,000 kilometers away in Russia's Leningrad region. This single facility processed 6% of Russia's oil. In 3 hours, it would process zero. At exactly 0200 hours, the lead operator initiated the launch sequence from inside a moving vehicle. The first FP-1 drone accelerated down its rail wings, flexing under the load. It lifted off at 80 kilometers per hour. Every 15 seconds, another followed, banking northeast toward Russia. The operators were already 2 kilometers away, racing through forest roads with headlights off, guided only by night vision. Behind them, the empty launch site awaited the inevitable Russian counterstrike. Across Ukraine, the same high-stakes race was repeated at dozens of other locations. There were farm fields in Sumy where operators launched from hidden bunkers, highway rest stops near Chernihiv where trucks revealed hidden launch rails, and factory rooftops in Kharkiv where maintenance crews were actually drone teams. In total, 361 drones were launched in a precisely timed sequence. But the coordination of the attack was remarkable for a specific reason. The Kirishi strike package was actually launched last, despite having the furthest to fly. They would burn more fuel flying faster at 200 kilometers per hour. Meanwhile, drones heading for closer targets cruised efficiently at 150 kilometers per hour. This backward planning meant all 361 drones would arrive within the same 20-minute window. Moscow, Bryansk, Smolensk, Rostov, and Kirishi would all face attacks simultaneously. Russian air defense commanders would be forced to choose which assets to protect. What happened next would reveal a fundamental flaw in their entire defense doctrine. Russian radar systems in temporarily occupied Donetsk detected the launches within seconds. These radars can track an object the size of a baseball from 60 kilometers away. To them, 361 climbing drones looked like fireworks on their screens. The data flowed instantly into Russia's integrated air defense network. Computers in Moscow began calculating intercept solutions. Fighter pilots across western Russia scrambled to their aircraft. But they were about to discover their defense strategy had a fatal weakness. Russia built its air defense network to stop American B-2 bombers, each worth $2 billion. Their S-400 missiles cost $5 million each. Their fighter jets burned $10,000 of fuel per hour. But these FP-1 drones cost only $50,000 to build. The economic math was breaking Russian doctrine. They could fire a $5 million missile at a $50,000 drone. Or they could let it through and risk a $1 billion refinery. Every option was a losing proposition. This was coupled with the fact that the FP-1 navigates using systems that cannot be easily spoofed. Its primary receiver tracks both GPS and GLONASS satellites simultaneously. If American satellites report one position, but Russian satellites report another, the drone knows one system is being manipulated. The backup system is terrain contour matching. The drone's radar altimeter constantly measures ground elevation, comparing it to stored topographic maps. Even with both satellite systems jammed, the drone reads the shape of the Earth itself to know its exact location. The engine powering this weapon is a Chinese two-stroke, available online for $500. It produces 6.5 horsepower, burns regular gasoline, and gives the drone a range of 600 kilometers. Ukraine did not develop exotic military technology. They adapted hobby shop components into strategic weapons. The warhead, however, was military grade. 80 kilograms of tetryl high explosive that detonates at 7,900 meters per second. It is surrounded by steel balls that can punch through concrete at 200 meters. By 02:15 hours, the strike packages had merged into one massive swarm heading east. Russian radar screens showed 361 contacts converging on dozens of targets. The question wasn't whether Russia would detect them. They already had. The question was whether they could stop them, At 02:45 hours, the Kirishi package reached the Belarusian border. The main swarm of 326 drones continued eastward toward Moscow and other targets. This was a critical moment. 35 drones peeled off heading north, threading a needle between Belarusian defenses and Russian interceptors. If detected now isolated from the main swarm, they would be easy prey. The package immediately split into what is known as a ladder formation. The Mugen 5 decoys climbed to 3,000 meters, deliberately broadcasting on known drone control frequencies. They were designed to be seen, tracked, and engaged. These modified commercial drones even carried radar reflectors, aluminum corner cubes that made them appear massive on radar screens. At $30,000 each, their job was to be sacrificed to ensure the mission's success. The UJ-22 drones leveled off at 1,500 meters, forming the middle tier. Some carried real 20-kilogram warheads. Others carried only ballast to match flight characteristics. Their role was to draw fire from Buk and Tor tactical missile systems, forcing the Russians to expend ammunition. The FP-1 strikers dove to just 50 meters, disappearing into what radar operators call ground clutter. At this altitude, radar beams bounce off trees, buildings, and vehicles, creating electronic noise that hides small targets. The Earth's curvature also provided cover. Radar travels in a straight line, but the planet curves away. At a 50-meter altitude, a drone becomes invisible to ground radar beyond 30 kilometers. Physics itself was protecting them. This ladder formation was ingeniously designed. Each altitude band was meant to defeat a different layer of Russian defense. The high-altitude Mugen 5s would trigger the S-400s and S-300 strategic systems designed for bombers. The mid-altitude UJ-22s would draw fire from tactical systems. The low-flying FP-1s would slip through the gap between these layers. The vertical spacing also meant no single missile could engage multiple drones. A missile climbing toward a target at 3,000 meters cannot simultaneously hit another at 50 meters. Belarusian MiG-31. Interceptors scrambled from Baranovichi Air Base. Their Zaslan M radars are among the most powerful ever fitted to a fighter, designed to track B-52 bombers at 300 kilometers. But that power was also a weakness. The radar uses narrow pencil beams, optimized for high-altitude searches. Trying to find small drones at treetop level with a MiG-31 is like using a sniper scope to hunt mosquitoes. The pilots locked onto the high-flying Mugen 5s immediately. But doctrine required visual identification before engaging. By the time they confirmed hostile intent, the real strike package had opened a 40-kilometer gap. The decoys were working perfectly, pulling interceptors high while the strikers slipped through low. But the drones had just entered the densest air defense network on Earth. Ahead waited an S-300 battery near Tikvin, equipped with its infamous cheese grater radar. The Ukrainians knew this radar had exactly one weakness. At 0400 hours, the package approached Tikvin, 200 kilometers from Kirishi. The S-300's 9S-19M2 radar began tracking them. This radar seemed unbeatable. It frequency hops across the X-band 100 times per second. It is impossible to jam, because by the time a jammer reacts, the frequency is already changed. But Ukraine had discovered its fatal flaw during previous strikes. Every 10 seconds, the system must recalibrate its frequency hopping sequence. For exactly 500 milliseconds, it stops transmitting. Half a second of blindness every 10 seconds. If you know when that will happen, you can disappear. One Mugen 5 climbed to 5,000 meters, deliberately triggering the radar. The S-300 engaged immediately, firing a $3 million 9N82M missile at a $50,000 drone. In the 2 seconds before impact, the doomed drone transmitted the radar's timing pattern to the swarm. Its destruction provided the synchronization data they needed. 27 seconds later, as the radar entered its reset gap, the remaining drones dove to 10 meters of altitude. For half a second, they were invisible. When the radar came back online, they had vanished into the ground clutter. The operators saw only ghost returns, perhaps birds or atmospheric anomalies. Without solid tracks, they could not engage. The swarm had slipped through the window of blindness, but they had just entered Russia's electronic warfare zone, where GPS itself would become a liability. The Pole 21 system activated using a technique called beaconing. It recorded real GPS signals and rebroadcast them with delays. The drone's receivers showed them over empty fields when they were actually over cities. For 5 minutes, all their position data was false. But this jamming attempt was ineffective. The FP1 drones switched to their backup navigation system. This system combined a magnetic heading with counting power line crossings. Each major transmission line between the border and Kirishi was a pre-planned waypoint. Following the Moscow-St. Petersburg energy corridor, there were 7 lines in total. The drones were navigating by counting infrastructure that could not be moved or spoofed. 2 drones flew over an iron ore deposit that pulled their compasses 30 degrees off course. 3 more followed the wrong power lines toward Finland. But the lead drone's power line count matched its flight plan. It was on course for Kirishi, the package now down to 24 drones, pressed on through thickening morning fog toward the refinery's glow on the horizon. At 0600 hours, the lights of Kirishi became visible. It was a glowing industrial city that never slept. 4 Panzer batteries protected it, positioned for overlapping fields of fire. The 20 remaining UJ-22s split into 5 groups of 4. Each group targeted a different Panzer battery. The operators watching their radar screens faced an impossible choice. Their systems could track all 20 drones, but each battery could only engage 4 at a time. Those 4 missiles would need 15 seconds to reach their targets. During those 15 seconds, the battery could not engage anything else without abandoning the missiles already in flight. Ukraine had turned the Panzer's precision into its weakness. 16 missiles launched simultaneously.
We have successfully recovered the drone power sources.
Their rocket motors lit up the pre-dawn sky like an artificial sunrise. The UJ-22s began evasive maneuvers. But against missiles pulling 30 G turns, physics favored the interceptors.
They were massive, crossing the checkpoint every
12
hour on the
UJ-22s
hour.
were
I'm
destroyed
talking
in
50 feet wide,
spectacular
minimum.
fireballs.
Never seen anything like it
Their
out here.
sacrifice bought precious seconds. Because while those missiles were in flight, and while the Panzer batteries were blind to new threats, the FP1 strikers sprinted through the gap. By the time the missiles impacted, the strikers were already inside the system's minimum engagement range. The Panzer batteries needed 45 seconds to reload. The FP1s needed only 30 seconds to reach cannon range. The math favored the attackers. The Panzer crews switched to their twin 30mm cannons, firing ahead ammunition. These are shells containing 360 tungsten sub-projectiles. The fire control computer calculated where each drone would be when the shells arrived, creating clouds of shrapnel along predicted flight paths. But the drones were programmed with random altitude changes every 2 seconds. Up 10 meters down, 5, up 3, down 8. There was no pattern for the computer to learn. The predictive targeting was firing at where the drones should have been, not where they were. 3 FP1s flew into tungsten clouds and disintegrated. Another caught the edge of a blast. Half its wing was gone, but it somehow kept flying, its gyroscope compensating frantically. 6 FP1s cleared the cannon envelope, now just 500 meters from the refinery. The Panzer crews could not depress their guns any lower without hitting their own positions. The drones had broken through the main defense, but the Russians had deployed a new weapon system. 3 surviving drones crossed the refinery perimeter at 0618 hours. They had just entered the engagement zone of a Derivatsia PVO. This is Russia's newest close-in weapon system, mounted on a modified BMP-3 chassis near the main gate. Its 57mm autocannon was already tracking the incoming drones. This was not just another anti-aircraft gun. It was specifically designed to stop drone
Yes, confirm
swarms.
the structural
The PVO
instability.
fires shells with programmable fuses. A laser rangefinder measures the exact distance to each target, then programs every shell as it leaves the barrel. The shell counts its rotations in flight, detonating at precisely the calculated distance, not on impact, but in front of the target. Each explosion spreads 200 tungsten balls in a
Pause it
10-meter
right there.
sphere.
Look at the calibration sequence.
The drone
Adjusting
flies
the
into a
servos too
wall of
quickly.
metal
That's
it
not
never
standard
saw
procedure.
coming. The system's
authorize this
computer
override.
was already calculating a firing solution
Our intelligence
called
confirms
barrage
Russia's
mode.
significant logistical struggle.
It would
They
create
simply
overlapping
cannot
spheres
replace
of
their
tungsten
downed
at different
UAVs at the-
distances. 300 meters, 250, 200, 150. A three-dimensional grid that nothing could fly through. The gun barrel began to elevate, targeting the lead drone at a 200-meter altitude. But the PVO's designers had built in a fatal safety protocol. Below a 100-meter altitude, the tungsten spheres could hit the refinery itself. Storage tanks could rupture, volatile chemicals could leak. The system trying to protect the facility could trigger the exact disaster it was meant to prevent. The safety lockout was hard-coded into the fire control computer. There was no manual override. The PVO opened fire at 0619.
Control,
The
we
first
have
shell
incoming
detonated
unauthorized
200
UAVs on
meters from the
Sector
lead
4.
drone,
Alert
too far
status
to
red.
cause damage, but close enough to reveal the firing pattern. The second shell exploded at 180 meters. The computer was walking its fire closer.
We've identified significant
The third would be on
structural weaknesses in
target.
the forward
The lead
fuselage bulkhead
FP-1
of the
tried to
UAV.
dive,
The stress
but its
modeling
damaged
clearly
controls
shows-
responded slowly. The third shell detonated 8 meters away. 200 tungsten balls expanded outward at on 500 meters per second. The drone's plywood frame shredded instantly. Its fuel tank was punctured,
These red
and the engine
markers
was torn
indicate
from
the
its
downed
mounts.
assets.
It cartwheeled
By
through the
analyzing
air,
the
spreading
telemetry,
debris over the
clear
refinery.
logistical pattern
The second
convergence
drone
image.
reached a 120-meter
Drone swarm
altitude. The PVO's barrel tracked downward, following perfectly. At 110 meters, it was still firing. At 105 meters, one more shell was ready. At exactly 100 meters, the system stopped.
Confirmed.
The
That's
barrel
significantly
froze in
higher than
position.
expected.
The final shell detonated harmlessly above the diving drone. The operator could see the targets, clearly tracked them perfectly. But the system would not fire. He tried manual override, but was denied. He tried switching to direct fire mode, but was locked out. The computer had decided that protecting the refinery from friendly fire outweighed stopping 2 drones.
The recent targeted
It was a
strikes
critical
have
mistake.
significantly
At
impacted Moscow's ability
0619,
to maintain
the first
its drone
surviving
fleet. We are
FP-1
seeing a
struck the
sharp
CDU-100 junction exactly where intelligence indicated. 25 kilograms of tetrol detonated at 7,900 meters per second, creating a 100 psi overpressure wave. The corroded supports failed instantly. Crude oil at 380 degrees Celsius and 30 atmospheres of pressure erupted from ruptured lines. The superheated liquid vaporized on contact with the air, triggering a fuel-air explosion that propagated through the entire complex. 10 seconds later, the second drone hit the degraded seal of Tank 47. The accumulated vapors ignited instantly. The floating roof became a 50-ton projectile launched 200 meters by expanding gases before crushing the administration building. 80,000 barrels of petroleum were now exposed, feeding an exponentially growing inferno. The failure of the CDU-100 cascaded through interconnected systems like a series of dominoes. The fractionator column, starved of input, experienced a catastrophic pressure drop. Liquid hydrocarbons at 380 degrees underwent an instantaneous phase change. This was a blev, a boiling liquid expanding vapor explosion. The 40-meter tall column split at its weld seams.
reading near the fuel
The top section flew 800 meters like
Check
a
the secondary
giant missile.
compartment under the chassis.
Secondary explosions ripped
This
outward.
manifest says you bypassed the checkpoint.
The
at
shock
Barstow.
wave from the
Why?
blev punctured 6 more storage
clear. I
tanks
was just trying to make up
simultaneously.
time, all right?
Emergency systems tried to isolate sections, but the damage was too widespread. Pumps couldn't stop, and valves couldn't close. The sprinkler system had no pressure. Water mains had been severed by the first explosion. The Kirishi Refinery, with a capacity of 355,000 barrels per day, or 6.4% of Russia's total, was destroying itself from within. Satellite imagery later confirmed what Russia denied for days. The CDU-100 was destroyed. The catalytic cracker was destroyed. It would take a minimum of 6 months before even partial operations could resume.
The recovery logistics have
Full
fractured,
capacity
severely
might never
limiting their
return.
strategic reach.
Russia claimed complete interception of all drones. The inferno visible from space told the truth.